righty. It is day 4 and it's quite late. I think the first day or second day was I was also late. But yeah, today I don't think uh, we have anything to do in terms of solving or whatever. I know I said like I'm going to do arrays and stuff and then maybe try a lead code or two. But the thing is, I haven't even watched the arrays lectures yet. I mean, I did 3 or 4, but there are the part one that is there is still remaining. So there are like 1, 2, 3, 4, 5, 6, 7 more lectures. So yeah, I nonetheless decided to start a recording because yeah, if I didn't and if I just studied on my own, then the day would be over, and then I wouldn't have anything to post. So yeah, I think I started. Yeah, I started the arrays, and then there were like creation of arrays, uh, input and output in arrays, and how to update arrays. As you can see here, this is an update function. So we have created an array here, and then we are updating marks by 1. Then again by for loop we are printing it. So here there is one document given which is space and time complexity, and okay, so in some videos you'll hear about words like space and time complexity of algorithms, big O notation, I guess, yeah, etc. And the concept of space and time complexity is covered in the later part of the course as an individual chapter. Yes, it is there. And but to be able to understand it before that, please reread this reading material. All right. Let's just give this a read and then we'll move to the lectures. I'll do it for like 1 or 1.5 hour, at least the recording, because then I'll also have to process it. The YouTube, like YouTube takes a long time to process this, to be honest. And yeah, so I'll have to upload it as well. So it's 10:15, 10:14. Let's at least do till 11:15. Let's see where we can reach, and then we'll see. Uh, my email is visible here, but anyways, you can email me, although I won't reply. Just kidding. You can. I'm not sure why would you email me though, but yeah. So okay, there is a scenario. So imagine you give 100 rupees to one of your friends. Okay, having them all together, uh, I don't understand this. What is this saying? Yeah, I give 100 rupees to one of my friends. Having them all together, you would like your pen back? Okay. Space complexity. Space complexity is represented as a function that portrays the amount of space necessary for an algorithm to run until it is complete. In our scenario, we are looking at, you can think of space complexity as the number of rooms you need to figure out. Who has the pen? God damn, what is this? Like, what is even written here? Having them all together, you would like your pen back. But I gave her 100 rupees, right? So where's the fucking pen here? And then you can think of as number of rooms you need to figure out who. Either I'm dumb, bro, or the person that has written this document is okay. Anyways. However, in computer science, this typically means how much memory does the processes and data structure in our code-based functions take up to achieve their goal. Okay. So as far as I can understand, other than the shitty example, is that it typically just means that how much memory does the processes and the data structures or algorithms or whatever functions take up to achieve their goal. that is the space or space complexity as it is. Now, time complexity is represented as a function that portrays the amount of time necessary. Okay, so this was amount of space necessary for an algorithm, and this is the time necessary. Okay. In our scenario, we are looking at time complexity that can be represented in the approach you take in finding out who has the pen. Okay, I think they are giving pen to some people, and then I guess taking an algorithm to figure it out. Again, the same thing as it is written here. However, in computer science, it typically means how much time the. Okay, I think. Okay. Anyways, let's just move on. I don't know about this document, to be honest. Anyways, time complexity, however, is an umbrella term for different types of time complexities that we can calculate. From fastest to slowest, they are worst case time complexity. It is. Ha. Sorry, the absolute most number of times an operation needs to be done before completed. Average case time complexity, which is the average number of times it will take for the algorithm to complete. Okay. Amortized running time, similar to average, it is the number of times the operation will take when run a sufficient amount of time consecutively. I am not understanding this, but anyways, best case time complexity, the fastest number of times operation needs to complete. Note, read. O brackets n as big O of n. Yeah, I knew that, I guess. Example of time complexity function, big O of n square. You ask one friend if they have the pen. You ask them, bro, imagine you give 100 rupees to one of your friends, having them all together. What the fuck? So you are giving 100 pen to, you are giving one pen to 100 of people. Like each one you are giving one pen, and there are 100 of them. So you ask them if the other, or you are giving one pen to, I don't. Okay. Uh, so you are asking one guy and then asking him again if the others have the pen. So that will be big O and square. And if we are asking just everyone one time, then it's big of n. And if you're dividing them in two rooms, and ask the person if the pen is in room 1 or room 2, and depending on which group has the pen, split them up into two rooms and repeat until there is one person in the right room with the pen, and you remember who has the pen, and then you go to them directly. Okay, so I think one guy has the pen. Anyways, something that is important to note that is that time space complexity of algorithm code is not in fact actual time or space that is required to execute a particular code, but the number of times a statement executes. Meaning the function is not a measure of time or space, but a measure of what the code is actually doing. Okay. Summary: there are multiple solutions that can be written for the same problem. We need to learn how to compare the performance of different algorithms uh, and choose the best one to solve a particular problem. Of course. While analyzing an algorithm, we mostly consider time complexity and space complexity. Okay, okay. Time complexity is the time taken by the algorithm to execute each set of instruction. It is always better to select the most efficient algorithm and a simple problem can be solved with different methods. Similarly, space is the amount of space or memory taken by an algorithm to run as a function of the length of the input. Uh, okay, time and space complexity depend on a lot of things like hardware operations. However, we don't consider any of these factors when analyzing the algorithm. We will only consider the execution time. So execution time is what matters in the end. I guess that's what I can take from here. And as this is a document, so yeah, I guess we'll understand we will when we go to the actual lecture. So let's just close this shit and let's just start with the lectures, I guess. So the next one here is linear search. Okay. So linear search is basically you go to a restaurant and you have one specific mind. Uh, you have one specific thing in your mind that I want to eat this, and so you look at the menu and you scan through it from the starting. That yeah, is it there? Is it there? Is it there? And then you find it and then you order it. Although I don't have any preference anytime I go to a restaurant. I just look at everything. So that will be the worst time complexity, I guess. But yeah. So yeah, it's the same thing with the arrays because you do like linearly you search for the key that you want. So let's just remove this, remove space from here, and let's say what the uh, int numbers will be equal to 2 4 6 8 10 and then 12 14 16. Then the key that we need to find is equal to 10. So yeah, let's just say we are giving an array as the input and key as the input, which we have defined right here. So we would say for int I is equal to 0 and length should be less than, or yeah, it should be less than length of the array, and then let's do it. So if array of I is equal to the key that we defined, return I. Or if it's not, then yeah, I guess this is return -1. Okay, so here we have defined the key as 10. So let's just give the input. Oh, what is this? Okay, sorry, it is returning an integer, so we can just store it here, and then we can just I think we were, yeah, I mean we can return the index or the key. It's nothing really of a problem. So yeah. We can just, for the sake of uh, simplicity, give the name as number, sake of clarity, not simplicity. So let's say 54 or something. Okay, so we cannot just say that the index of 54 is -1. We will have to like write a loop. So if index, uh, yeah, else this thing. Let's just put it in the braces. Okay. So we can do the same thing with number, sorry, a string. So let's say menu, and just remove all of these. Let's say, and I don't want pizza burger, I want to go desi. So it's samosa, then it's a puff. It's not that puff if you're thinking, it's patties or whatever you might call that, but yeah, it's called puff only. And then it's chole kulche. Wow, I miss them. And then there is veg roll. Okay, I should not go overboard and just end it here with the, what am I writing, diet coke. We can just add dosa, sorry, veg roll. I did not want to disrespect you like that. Key is, let's say, puff. So we'll have to search that. And yeah, so let's say menu here. We can say that, right? I think we can. Menu dot length, whatever it is. Menu dot I. Sorry, menu is equal to key. God damn, I'm so sleepy. Okay. Will this work though? I'm not really sure. Let's just try it. See? What's the issue? String cannot be converted to int. Alright, homies. I think I've gone insane. Because I'm even forgetting the data types. Okay. Now is it alright? Int index. Yeah, it will return an index. And okay. Now it should be okay. Again, string. Okay, I've not just saved it only. No, the index of puff is okay. Yeah, it is one. What am I saying? Let's say diet cook. And let's say if you are a pizza lover and you're trying to find the pizza in my menu. Uh, we can just keep it as it's not in the menu. Okay. Pizza is not found in the menu. And if I say samosa, then okay. I mean, what else can be done, right? Because if you are saying, if you are giving the key as samosa, and then if you are trying if samosa is in there, then return samosa. How does that make sense? But yeah, anyways. So yeah, I don't think there is any error. This equal to is working fine for now. So yeah, the time complexity for linear search will be big of n because it takes n operation, because it will go through this, and in worst case it will go till diet coke. So it will go till till the length of the array, which so yeah. Okay. Okay. Just a second. Mm, so next up is largest in array. We have to find the largest number in the array, and what should I do? What the fuck, bro? I need to turn on this heat is just killing me. I don't know if it is because of my headphones or what, but yeah. So yeah, let's go. Okay, so let's just remove this and make a new array and numbers, which has 1 2 3 say 1 2 6 3 5, let's say. And then so what we are doing is, let's say largest num. So we are just giving it an integer type of array, which is numbers. We are giving it int largest num, and we are saying int largest num is equal to integer dot min value. So this utility package, it gives us this minimum value in integers. So first it's gonna be that's gonna be the largest, because we need to check if there is any larger in the array. So yeah, again it will go to numbers dot length, and if it is equal to, no, if it is greater than largest numbers of I is greater than largest number, then return numbers of I. And then so yeah, I think how will we return here? And oh, for I is equal to 0, lessest, I'm not sure actually. Okay, so we are not passing this. So if we just want to pass the array, and we're initializing the thing here. So let's remove this, and okay, so yeah, I'm fucking stupid. I need to do not return anything. I need to just do, yeah, update the largest number, and then return largest number here. So yeah, my bad guys. Okay. All right, that's how it is done. Uh, and same thing we can do with the smallest. Let's say max value here. and if numbers of I is less than the smallest, then smallest will be the numbers of I. That will be what we get here. Smallest number in the array is okay. Why there is an error? Okay, we have not updated everything. Yes, and it has found the number 1, which is the smallest. Okay, so this is the complexity for this is also the big of n, because we have run one for loop and it is performing n operations on the array. So yeah, next up is binary search. Okay, so I was thinking what I should do. It has been half an hour, I guess, and there is there is still something remaining, which is binary search, and then there is reversing an array, and then there's pairs in array and sub arrays and stuff. But again, I also need to do. So I'm not liking this one thing, which is just that I'm having to do that project that I'm mentioning again and again, and I cannot just record that and code it here, because if I put it out there, I know no one's seeing this video and I'm getting no views, but still, if someone gets this and sees that, then I'm gonna be doomed. So, yeah, it is gonna be like this for at least 10 days or so, but yeah, in that time, hopefully, I'll start doing lead code, because I'll study many of the topics, because arrays I'll try to finish tomorrow, but I'm not sure. Then there are sorting algorithms and 2D arrays and strings and bit manipulation and oops recursion. And as I saw, there were so many questions on lead code, so there is no kami in content, basically. What would you say that in English? There is no, what's that word? It's not clicking right now. No shortage of the content. Yeah, that's the word I was looking for. Okay, so I think I'm gonna wrap it up here. Even though I said I'm gonna do it for an hour, but I also need to upload this and then get to the project, because if I don't, then I'm gonna be running late and running behind, because I have like the deadline is 30 and I'm just getting started. So, and obviously I'm gonna face so many errors, because Flask is just shit. and then I also need to learn Vue for the front end part. So yeah, anyways, that is it for today. I know it's like a shorter video than others, but yeah, that's gonna do it for today. I think it's day 4. Yeah, it's day 4, and erase. We will try to finish tomorrow, and pray for me that I can start actually doing lead code from tomorrow. So yeah. Anyways, have a good night, and signing off as usual. We'll be seeing you tomorrow. So yeah.